First, let's talk about rectangular coordinates. We're going to begin with two real number lines located in the same plane. One is going to be horizontal and the other vertical. Yep, just like that. The horizontal line is going to be called the x-axis and the vertical line the y-axis. And this point right here where it intersects, that's going to be the origin. The coordinate system described here is called a rectangular or Cartesian coordinate system. The plane formed by the x-axis and y-axis is sometimes called the xy plane. And the x-axis and y-axes are referred to as the coordinate axes. Any point P in the xy plane can be located by using an ordered pair that looks like this of real numbers. The ordered pair, also called the coordinates of P, then gives us enough information to locate the point P in the xy plane. If xy are your coordinates, then x is called the x-coordinate or abscissa, and y is the y-coordinate or ordinate. The coordinate axis divides the xy plane into four sections called quadrants, just like this. The quadrants start with quadrant 1 in the upper right-hand corner and go counterclockwise to quadrant 2, 3, and 4. For quadrant 1, both x and y are positive. And for quadrant 3, both x and y are negative. Let's do an example where we find the distance between 2 points. We're going to call this distance d. The first point is 0, 2, and the second is 4, 5. First, we plot the point 0, 2, and 4, 5 on our coordinate system. Then we connect them with a straight line and call it d. To find the length d, let's draw a line from 0, 2 to 4, 2 horizontally, and vertically a line from 4, 2 to 4, 5. This forms a right triangle. One leg of the triangle is of length 4, since 4 minus 0 equals 4, and the other is 3, since 5 minus 2 equals 3. By the Pythagorean theorem, we know that the square of d, the distance we want, is going to be the sum of the square of each of the legs. Take the square root of the sum, which is 25, and we get that d equals 5. From that example, we can actually create a distance formula. The distance between 2 points, P1 and P2, denoted by D, P1, P2, is exactly what we see here. It is equal to the square root of the differences in x squared plus differences in y squared. And a hint from me, write this one down because you're going to need it. Let's do an example using our new distance formula. Find the distance d between the 2 points, negative 4, 5, and 1, 3. Let's let P1 equal negative 4, 5, and P2 equal 1, 3. It doesn't matter which point you pick for P1 or P2, as long as x1 matches y1 and x2 matches y2. Now, let's get our distance formula from before. Yep, just like that. Now, plug in the values for x1, y1, and x2, y2. Now, a 1 minus a negative 4, that gives me 5. And 3 minus 5 gives me negative 2. 5 squared is 25, and negative 2 squared is 4. And finally, 25 plus 4 is 29. So our distance d is the square root of 29. Let's look at a quick example of using algebra to solve a geometry problem. Let's look at 3 different points, A, B, and C. We're going to do a few different things, but first let's plot these points. First, we need a coordinate system. Now let's plot A, B, and C. Now connect all those points into a triangle. Next, let's find the length of each side. And for this, we don't need the graph anymore, but we do need our equation. Let's find the distance from A to B first. So let's plug in negative 3, 1 and negative 3, 4 in for x1 and y1. If you need to pause here to see what's going on, that's fine. I'm not going anywhere. We're going to do the exact same thing with points B and C, and then points A and C. Again, if you need to pause this, go for it. Lastly, let's find the area of the triangle. So let's get our picture back. Because the right angle is at this vertex A, the sides AC and AB form the base and height of the triangle. Your area equals 1/2 base times height, and plug in the numbers from part B. So now I know that the area is 21/2 square units. Let's move on to a new equation. So now we can put together an equation for a midpoint formula. The midpoint, which we're going to call M, has coordinates like any other point, x, y. And it is the midpoint of the line segment from P1 to P2. So we can use an equation with P1 and P2 to find the values of the midpoint. Another way to state this equation is the average of the x's and then the average of the y's. This is another equation you need to make sure is in your notes. Let's do one last example for this lecture today. So let's find the midpoint of a line segment from P1 equals -4, to P2 equals 4, Plot P1, P2, and M. First, we're going to start out with our good old midpoint formula. We're going to apply the midpoint formula using x1 equals -4, y1 equals 4, x2 equals 4, and y2 equals 2. Then the coordinates of xy of the midpoint are, just plug and chug into our equation. Take x1 and x2, and we get a value of x equals 0. Take y1 and y2, and we get a value of y equals 3. So our midpoint M is going to be the coordinate 0, 3. Once we bring up our graph, we can see that this shows a line segment from P1 to P2 and the midpoint at M. For additional help in this section, please refer back to your book in sections A1, Algebra Essentials, and section A2, Geometry Essentials.